friend, welcome you all. Myself, Dr. P.P. Joshi, working in the Department of Mathematics. Today's topic is linear form, that is another method of solving first order and first degree differential equation. This form is also known as Leibniz linear equation. Actually, Leibniz has provided a procedure to solve this linear form. Therefore, it is also known as Leibniz linear equation. The linear differential equation of first order and first degree can be expressed in the standard form dy by dx plus py is equal to q, where p and q are either constants or function of x alone. That is, its p and q are either constant or functions of x alone, that is y should not be involved in any one of the function p and q. Then this form is known as the standard form or general form of linear differential equation of first order and first degree. And in order to find its solution, Leibniz has first evaluated the integrating factor. Integrating factor is basically an expression of function, an expression or function of x, either x or y or even both the variables. If we multiplied the whole equation by this function or this expression, then this equation can be easily solved by integrating both the sides. So this is the concept of integrating factor. So if we multiplied the whole equation by e raised to the power integration of p dx, then we obtained this equation. Now rewriting the term of left hand side by using the product formula, d by dx of y into integration e raised to the power integration of p dx is equal to, that is derivative of first function dy by dx, this is term, into second function as it is, plus first function y as it is into derivative of second function. Derivative of e raised to the power integration of p dx is same. Now by chain rule, differentiation of this term, that is p. So therefore we can directly solve this term or this equation by simply integrating both the sides. So this is the general form of solution of linear differential equation, which can be written in the form of y into integrating factor. Integrating factor is e raised to the power integration of p dx equal to integration of q into integrating factor dx plus c. So this equation dy by dx plus py is equal to q is linear difference. So sometimes it is given as the linear differential equation now in variable x. Suppose the corresponding differential equation can be written as dx over dy plus px is equal to q. In this situation, p and q should be either constants or functions of y alone, that is, it should not contain the independent variable x. In such cases, the solution can be represented as dependent variable, that is x. In this case, in this equation, the dependent variable is x. So its solution is x into integrating factor. Integrating factor is taken as e raised to the power integration of p. The independent variable is y. So we have to integrate this function p with respect to y is equal to integration of right hand side function q into integrating factor, again integration with respect to y plus c. So by this equation we write the solution when a linear differential equation is given in variable x. Suppose this differential equation, we have to solve this differential equation. So in order to write its solution, we have to first write this differential equation in standard form, that is dy by dx plus py is equal to q. That is, coefficient of dy over dx should be 1, that is unity. So in order to make the coefficient of dy by dx 1, we have to divide the whole equation by x cos x. So dividing the whole equation by x cos x, this is the modified form or reduced form. So now comparing with this standard form, this function is our p function and this function is our q function. And next integrating factor, e raised to the power integration of p dx. Simply e raised to the power integration of p function. Integration of 10x is log sec x and integration of 1 over x is log x. So therefore by using the property of logarithmic function, e raised to the power log m plus log n is equal to e raised to the power log m into n. And additionally we know that e raised to the power log of a is actually equal to a, and the base of log a should be e. So therefore integrating factor is x sec x. Therefore the required solution is y times, that is dependent variable, into integrating factor is equal to integration of right hand side function into integrating factor plus constant of integration. Now simply integrating this term, we have this required solution where c is the constant of integration. So another example is taken as y is equal to suppose we have to solve this differential equation y log y dx plus x minus log y dy equal to 0. So rewriting this differential equation, dx over dy plus, here as it is clear that linear means, suppose if we are writing this differential equation in the form of dy by dx plus py is equal to q, the degree of y and dy by dx should be 1 in order to state that this differential equation is linear. Here y log y is term is involved, so it is not possible to write this differential equation in terms of linear differential equation with variable y. Therefore we are now trying to write this differential equation in the form of dx over dy plus px is equal to q, as the power of x, exponent of x is 1, and the exponent of dx over dy should also be 1 in order to say that this equation is linear in variable x. So by observing this equation, it is clear that the power of x is 1, but the power of y is not exactly 1. So therefore it is not possible to write this differential equation into this form. Therefore we try to express this differential equation in this form. So we write simply by evaluating the coefficient of dx over dy and dividing the whole equation by y log y. So this is our reduced form. Now comparing with this standard form, here p function is 1 over y log y, that is purely function of y, and q is 1 over y, again purely function of y. Now integrating factor in this differential equation is e raised to the power integration of p with respect to y, as y is independent, y is taken as independent variable. So integration of e raised to the power 1 over y log y, considering log y equal to t, 1 over y dy equal to dt, therefore integration of 1 over t, which is log t, that is log y, again with the help of the property of logarithmic function, e raised to the power log a is exactly equal to a, therefore log y is our integrating factor for this differential equation. So in order to write the solution is x times, that is dependent variable x into integrating factor, equal to right hand side function, that is 1 over y into integrating factor, again integration with respect to y plus c, that is c constant of integration. Finally solving this differential equation, this is our required solution where c is the constant of integration. Thank you so much.